Hello and welcome to the second part of Simin tutorial. We are going to start to create this model from scratch. So we will build this template for stitching, and I will try to show you how to make a template very stable as well. And let's start. So first thing is to rename the part, as we will not call it physical product. We want to have it some reasonable name on it. So this will be sim base, as we are going to build the simming tool, which contains out of two levels. First level will be the base, where the only simple element will be created with its supporting surface, and afterwards we'll create the line which is applied on surface. In order to do this, we will need this part, we will need a couple of geometrical sets, we will need one set with references, so this. And in this set we will have to have axis system. This axis system is by default created in axis system container. We will not need that. We will need one axis system which is included in our references set. So we will add additional axis system, and we will turn off the option under axis system node. As we want to use default orientation, we will not modify any of these parameters. So confirm, and we will isolate this element. Why we are isolating it? Because we don't want to have any references to outer world. We want to have everything inside of our geometry. So we can delete this. We can even rename this axis system to main axis system, and we will use this axis system for all our purposes later. As well, this will be practically only element where we will use boundary representation, so-called B-rep. Why is this important to say? Because depending on the boundary representation selections, we will define how stable our model is. So, for instance, functions like edge fillet or functions like trim are actually very bad for your models, and they are actually very unstable functions, as they can be modified. Their definition can be modified very easily if you have multi-patch surfaces. So it can happen that they lose orientation, that they lose the reference of the edge that was selected, and similar. So we will avoid to use those. In this case, we have this main axis system that we created, and we said we will use B-rep here, because in this case this is not an issue, as this is static element which is already isolated. It won't get modified, so its references will always stay the same. So if you select this plane here, we are always going to know that this element was selected. If we were using the outer one, which is not isolated, it could happen that when we are transforming this into the new part, that the part will lose references. So we have references set, then we will need a couple of other parameters, so let's add them. So let's add a couple of parameters. They are hidden under the tools and formula. We will need a couple of parameters of type length, and we will need one real for this model. So let's start creating them. We want stitch length. We'll define it as 4.5 millimeter. Then we will add stitch gap, because for a realistic appearance the thread itself is not touching by two seams. So we will add this gap as basic parameter of 0.5 millimeter. Then we will have offset parameter. This parameter will give us possibility to move the stitch up and down on the surface for a more realistic appearance. then we will have of course the thread itself, and in this case we will define it as stitch height with parameter 0.4 millimeter, and we will need additional parameter for the width of the stitch, which we will define as a 1.8. Why we are not using standard circular element from 0.53 millimeter? Reason is very simple. When thread is applied on the surface, it usually gets a bit squeezed, and that's the reason why we are losing some height and gaining some width, which gives us then more realistic appearance. After we confirm this, our parameters are created again in one set which is outside of that place where we want to have it, so we have possibility to grab this and put it inside. In this case we don't need the container itself, we just need those parameters, so we'll just drag and drop them over. So this container we don't need as well. And now we have defined all the parameters that we will need in order to create this model. Additionally, we will later add some relations into this set, but relations will be created afterwards, and then we will transfer them into this set so that we have everything in one place, so that we have minimal amount of inputs later when we are creating templates out of it. Then we will need a couple of geometrical sets where we will structure our geometry. In order to do that, we have to add geometrical set. They are unfortunately in 3D Experience as very useful function that we need all the time, unfortunately hidden very well under the additional triangles under this slide out menus, but still we will create a new element. We will select this references, we will put it inside, so we'll call this sim base, and then inside of this sim base we can add additional geometrical sets. We will need the set for the shape and of course for the surface, basing surface, so let's add them. We can just simply select element, and we have now possibility for using this quick shortcut, so let's use the shortcut. Call it the stitch shape. Then we will have additional one for the base surface. So let's start creating finally some geometry. We will activate this stitch shape set. Then we will add a couple of points in beginning. First point will be on origin, so we'll simply add 0, 0, 0 from main axis system. Other point will be slightly more complicated, as we will use the x as a formula, which we will create from our references. So we will use stitch length, where we will deduct the stitch height, and we will deduct as well the gap. And we will of course additionally divide this bit by 2, as we want to have only half of the dimension. So this will give us 1.8 millimeter in this case, as everything is very small. Let's zoom in. So we are getting our point, and now we can as well add one plane, which will give us the bottom plane where the geometry will lie on. This plane here, XY, is defining where the surface itself is. So let's add one offsetted plane from this XY, and here as well we'll define it as formula as 1.5 times the height of the stitch, 0.5, which will give us 0.6 millimeter, and additionally we want to go down without changing really orientation, so we have it on 0.6 millimeter below. This of course we can see here. Then we will add a couple of lines that will support our geometry. So first one is coming from our basic point in direction of X. So let's do it. So point in direction. So this is just a support. Let's define some reasonable length, and we will switch direction. So we'll switch direction. Additionally, we need another one, and then we'll simply blend the curve between. So other one is created from this point in Z direction, where we will define this basic point start from this plane. So we will add the formula. Where we will use this offset, and we will lock it with offset together. So we'll have 0.65 millimeter, and then additionally, where are you? Reverse. We want to go slightly outside. So just be sure that this line is long enough. After that we need one point, which we'll add here. Of course we don't want to use a B-rep, as this might lead to instability later, so we will simply create a point on this curve, where we will define that is coming from where we will define it from start of the curve on parameter 0. This is value that always can be found on any single curve, so this will give us a stable result. In order to blend those curves, we will use the connect curve function, so we'll select the point, supporting line. If it's not selected, select it alone. Then of course for the second point, select the point and support. In this case we can see that the orientation is wrong, so we'll adjust the orientation. And now we can play as well with tangency. On the center of the seam itself, we want to have a curvature symmetry, so we will modify to curvature, and this can give us a bit too tight result here, so we will slightly relax it with 0.8 tangent factor on both sides, so we'll have nice transition here. After that we don't need anymore those supporting curves, we can simply hide them. Then we can select our stitch and half of the stitch and symmetrize it. So we'll use from transformation symmetry, we'll select again this axis system, because this is only axis system, it will always select the correct one, and then we will simply join those two elements. After this we will position it on initial state, where the position of the element will be on the -1 of the pattern that will be used later. So we will move the geometry on -1, and then all pattern will be created on other side. In this way we can avoid one join later, and avoid issues when we have only eventually one element created for a stitch. But before this we will have a couple of other actions, so let's see how this has to be done. We will need one point where this stitch itself is coming out, so it won't start from 0, 0, 0, or it will be moved slightly behind, and it will be of course on 0.65 millimeter below. So let's add those 2 points. We'll need later both, so let's create point. First point is on coordinates, where we will define the parameter for the point through the formula. We will define it as a negative, because we want to go on the opposite side, negative half of the distance between gap plus thickness of the element, so height. This will give us 0.45 millimeter. An additional point will be created from this point, from this reference point, so we'll simply select this reference. Always prefer to select elements in tree, because elements selected in tree usually are working with whole objects and are much more stable than elements that you might select in the 3D view. Problem with 3D view is that you can easily access the vertices instead of points, and then you will have boundary representation problems. So we have our x is 0, z will be defined by formula. We will put it on the same point as the second line was starting from. So we'll select simply same parameter, reuse it, and we'll have the lower point. Then of course we can grab our element and transform it from point to point. Why point to point? Because like this we know always the distance between elements. Technically we could in this case define it as well with a regular translation, but we would have to calculate how long this half is, and this parameter, so I consider it simply easier to manage to add this point on a new position where we want to keep it. So let's transform it. Translate point to point, select the object, select first point, select second point, and we'll have the geometry in new position. After this we can even hide the join, as we will not need it. And as well, you will see that now this point is below this plane, and we want also our stitch always to stay on the plane, starting always from the plane, so that we can manage the floor, eventually to close it and to trim it in order to make model printable, for instance. So we will translate one more time, translate in Z, direction, point, direction is Z, and the distance is of course our offset. Okay, and we don't need lower one, and this point now starts exactly from the plane. Why did we spend so much effort adding this offset? Reason is relatively simple. So this gives us possibility that we change it. For instance, 0.25, if we confirm it, and after we updated the element, you will see that the center of the stitch itself came up on 0.25 millimeter from the main plane, while the point is still kept here on the plane. So we can revert back to 0.05, and this is important because this gives us possibility to additionally control the shape of this element afterwards. In this way we created the guiding curve of our stitch. The profile itself will create in a moment, but as this is all what we here created, the guiding curve, let's just pack it into the additional geometrical set. Guide. And then we'll have additional set for the profile itself, so we can as well add this profile set now. Profile. I always recommend to structure data to the containers, as it's later easier to manage it and to find the data and update it in case of need. Before we continue, we will simply save this model. So Ctrl S. So let's try to create the profile of this seam itself. In order to do that, we will put one point here on the beginning, which will define where the stitch will lie, the profile will lie on, As well as this point is always on the plane, we will not recreate this plane, as we don't need additional one. We can guarantee the position, otherwise we could create the point and normal to the curve through this point. We could add additional plane which will do the same, but as they would be the same, we will not add it. So let's first add the point on the curve. So we'll select point and we'll select the curve and adjust the orientation, and of course put it on 0. So we have point in the beginning. Then we can add the sketch. Sketch will add on the position. In case that this wizard is active, deactivate it, otherwise it will automatically jump into the sketch even though not all the parameters are defined. So we want to select this plane. Then we want to have origin exactly on this point, so we'll project this point. And as well, we want to define the direction, so we can select here y-axis as our main direction, and v direction we will as well reverse, so each direction reverse v. And now we can start creating our ellipse. So we'll select ellipse. From this point we'll define 2 points, and now we will add dimensions on it. So we'll take the semi-minor axis, later we'll define the parameter, we'll define the horizontality so that it doesn't rotate additionally, and of course we have to define the length. So let's start. Formula. Height is of course exactly this. Unfortunately, from some reason 0.4 will be doubled, so we have to half it of, even though this is defined as a full length, not only as a radius, or a half of it. Same procedure for this one. Funny as well that these menus are bigger than the text is bigger than the menu itself. Anyway, formula. So we'll say we want our height. As said before, we want to control this width with this parameter, so we'll multiply it. As well, everything will be divided by 2. As well, this we want to the whole length defined only once. So we have our sketch. Additionally, we will cut off the bottom. So we'll cut off. We can delete it simply the lower part, and now we'll define this length here as well with a parameter. So we can select it even with left button and choose the formula. Formula will be 75% or half, or whatever number we consider big enough so it is not visible underneath the edge of the element when the stitch is lying on the geometry. So we will multiply this number with 75%. Multiply. And we will of course declare this as a construction geometry. I would always recommend fully defined sketches so that you don't have any surprises when the parameters are changed afterwards. And of course we can see now that our cutout is on the wrong side, so let's flip it, change sketch support, reverse way. So we have now our profile that we will sweep through the guide. Before we do this, we will just in guide do one more change. We will simplify this curve in order to get rid of this vertex in the middle, because we don't need it, and that vertex later will generate additional face which we don't want to have. In order to smooth this curve, we will use curve smooth, which we can find in in, transform under the join, so curve smooth, select the curve, and modify the continuity type to curvature. So vertex will be removed if the topology simplification is activated. As well, deviation will be 1 micrometer, so that we don't have practically any deviation from this shape. And now we can do simple sweep. We'll position this sweep as well in main container, as this is only result that is interesting to us. So sweep of this shape on this profile, put on this profile on this guide, and now we have the shape of our element, which we can afterwards modify by modifying those parameters. This will be it for the shape itself. Now we will start creating the surface on which this shape is lying. As we don't want to just put this stitch on top of the shape, we want to generate nice protrusion and volcano styled shape with cutouts on which this stitch is lying. In order to create a supporting surface, I will first activate this supporting surface set. We will do that by activating define work object, but instead of clicking here, we will just click F, press F on the keyboard, and now on this plane we can start creating the sketch. Then let's add the sketch. We'll select the sketch, turn off this wizard, select the plane. Orientation is in this case fine. We could additionally attach it to the orientation of the specified orientation of this axis system, but as this element won't change afterwards, we will not do that. Unfortunately, Sketcher in 3D Experience is putting the sketch in strange position instead of expected one. In that case, we will simply, with normal view, reorient it, and then we will create additional ellipses. So we'll have our ellipse, which will be slightly smaller than the width of this element in order to close the hole nicely. So let's put couple of dimensions on it. We will adjust them afterwards. So this one is the semi-minor, and we need as well horizontality so that it becomes fully defined. And now we'll cut the half. In order to do that, we'll simply position the line somewhere and delete unnecessary parts of it, and we will make this line coincident with the V direction of the sketch, and additionally we will define this element as a construction because we need only this curve actually. And now we can speak about the sizes. So now we'll change the formula of this height. Edit formula will define that this is 80% of this width, and it's 90% of this width, pardon, 80% of that half. So let's select this element, multiply it by 0.8. So this element is slightly smaller than the width of the element, which is 0.72 in this case. And as well, the width we have to define as well from this formula, where we will add additionally half of this, half of the height on top. Edit formula. So let's calculate it from here. Let's add the height, half of the height. So that we have nice shape later. So this is enough. Exit sketch, and we have bottom curve, bottom element in which this stitch will dive in. Then let's create the upper support of that blend. We'll create it from this curve, which will now project on XY. We don't need the direction, as we want to project it on the plane, and plane direction itself is enough. Then we don't need, in fact this one we do need. So then we will make a parallel curve from here, 1.2 millimeter, but not inside. We want the other side. So we have upper curve. As this upper curve doesn't have a really nice shape, we will attract it a bit more with affinity. So affinity of this curve with origin is default, the XY is default, X is default. We can reselect them again, but won't make much difference. So point plane X, and we will define parameters for the scaling. In X double, and in Y we'll reduce it slightly. With this upper curve we don't need anymore, and now we'll need the support surface so that we can make a blend. As a support for this upper surface, support for this support curve of the blend, we will create one simple planar face, which will have the length of the stitch. So I did formula, we will just connect with the complete length, and we will extrude it somewhere. Extrude in Y by double amount of formula of this parallel curve, so that we always can guarantee that we have support. So, and as this is supposed to be symmetrical, let's activate it. We said double, so let's double it. So now we have supporting surface for this blend, and in order to do the blend, we will create a blend from this curve and this support on this curve. As they are coming from the same origin, both curves, their orientation is as well always same. It's tidally locked. So additionally, we will need the curvature. If it was tangency, switch it to curvature, and we want to have a bit more tension. So instead of 1.1. If we see the preview, we will see that now this volcano shape is created. This surface we don't need for now. Maybe we'll not need it at all. But we have a basic shape of this blend, which we will now cut, mirror it, and blend it between, so that we have a nice transition between two elements, so that it follows this kind of this shape. They are never 100% correct, but for realistic appearance they even shouldn't be. So let's cut this part of the shape that we need, that we want to keep. So we want to keep slightly more than this cutout is. So we will cut it somewhere there, 10% more than this inner ellipse is sized. So let's do it. So for that we need one plane, wireframe plane offset, and parameter of the offset is edit formula as usual, and we will take it from this sketch, where we'll take this size, and as this size is too big, we will half it. Did we select the wrong one? They did. We'll select the correct one, which gives us 0.2 millimeter, and we'll add 10% on it. As we can see, this plane is now outside of this element, and now we can split this geometry. So split, very good. So let's try to find split somewhere. Select the surface, cut the plane. It's mandatory that it stays outside, otherwise we will lose the blending possibilities later that we need. And additionally, we want to keep intersection. So we want to compute this intersection inside. Now we have enough information that we can make other side and blend it together. In order to make symmetry of this element on the other side, we will have to prepare the symmetrical plane. And where this plane is, relatively simply said, we'll need this curve. We will translate it, translate, and direction will be x, and distance will be, of course, formula as usual, and value is, of course, stitch length. So we want whole distance, and we will get it exactly there where the second stitch will come. Why we want this position? Because now we can simply in wireframe select the plane, put it normal on the curve, and of course by default it will be in the middle, and that's exactly where we want to have it. So we can grab even these elements and make a symmetry. Transform symmetry over this plane, and there become another side. So now we will need a blend between these two elements. In order to do that, we will make from this part of the curve, we will symmetrize them as well, and we will make a blended curve on support of that, on that plane that we, on that surface that we used for a blending, so that we always can guarantee that we are aligned in the same plane. And then we'll make a simple fill between. As element is symmetrical as well in the on the ZX, well, we need only to create one element. So how to do it? Principle is quite straightforward. We need two lines that will blend. In order to do that, we will use this curve, which will split with this curve here, and we will keep this element here. How do we do it? That we can keep it in the correlation that is always found and won't cause the update problems. We will do it with splits and keep options instead of just splitting it generally and undefined and leave it undefined. So first we will add a point on this curve, of course, as usual on 0. Then we'll select other curve and reverse direction and put it as well on the 0. And now we have enough information to split this element. So we'll use split. We'll select this element, and I want to show you as well additionally that this element, this affinity, we don't want to know where we are selecting in order to keep some side. So we want to select this element, we want to select that point, and now we want to define which side is going to stay. So element to keep is going to be this point, defined by this point. So now, regardless what orientation we have defined in the function, somewhere it's supposed to be other side functionality, but regardless of what is defined there, we always have position defined by this point, and it will always keep the element that is near to this element. So as we made a symmetry already, we can just attach this element to it. So we'll select this symmetry, we'll open the list, and in this list we'll add additional element. Okay. As those are ellipses, we will have turn in and out. So let's do this. So in order to do this, we need blend curve. Blend curve was here. In order to do blend curve, we again need the point here, which we will as well take from the other side. So let's open this symmetry, let's attach this point as well. Okay, and now we can do the blend. So we'll select the point, we'll select the curve, we'll select other direction only once, then we'll select the other curve, other support, and we will additionally project this on our desired surface. And the surface was that extrude that we created before, so let's project it technically, as this is flat curve, it's supposed to stay on that same surface, but let's keep it simple. Let's project this on the extrude along normal, and we can hide this element. Now we have three sides of this quad. In order to get the fourth, we will simply make a symmetry of this curve over ZX plane, and now we can fill it up. Essential somewhere is a fill, so we can select the first curve, first support, second curve. Support for the second curve is again that extrude, third curve support, fourth curve again plane as a support, extrude as a support, and we will use just a simple tangency preview, supposed to give us nice surface in between, which we can now join together. So we'll take these three elements and additionally at the end we will symmetrize it. So we'll select this element, transform symmetry over the ZY and confirm. Rest of this geometry is just a supporting geometry, so we can just select it and put it with set. Where was the geometrical set? Hidden again. So in one set, why did we put it there? So that we can hide everything at once. Same with these two guides, from guides and profile definition of the shape. And now you can see we have our element, basic element created. Now we will prepare it for templating. Before forgetting, actually we will need additionally this curve later for splitting the geometry correctly, so we will as well take that one. First we'll make a join, make a symmetry out of it, same as the previous one. You can position it in this set, as this is important geometry for us, and as well we will make a symmetry once again over ZX. So now we have all the references necessary later for the trimming the main shape. Before we start making template, we will move as well relations into the references. So let's grab it in. Model will temporarily lose all the references as this formulas were deactivated during this period, and you can see instead of relations 1 we have now 2, but as the relations are, regardless what they are, how they are named, they are going about their content, so we can still update our model completely with these relations, new relations. So now everything is re-related through this set of relations too. Now we have everything, and we can make a user-defined feature. Let's say first, to make a user-defined feature from this element is actually quite trivial, as it doesn't have a real input in geometry except those parameters. We will simply pack everything as a block so that later we don't have to cope with the whole history in case that we don't have to scroll through it and so on, so we have one feature out of it. And in order to do that, we will go into the tools, select user feature. It can be as well power copy, but power copy will expose whole history, which we don't really want. We will select our sim base, whole block. We'll rename it as sim base. And now we will define, of course we don't have any inputs in this case, meta inputs as well. Parameters that we want to expose are, in this case, those parameters that we predefined. So let's expose them. We can see that those parameters are exactly those that are staying here. Is symbase references and then name, symbase references and then name of the parameter. Rest we don't want to expose, rest has to stay hidden. Then we have as well properties. We want it black box protected, or as well you can choose different options in order to debug element. White box will keep everything practically same as the power copy. Preview is kinda useful. In this case we can make a grab preview and we will have a picture of this element. We can as well hide the tree, so grab screen so that we have nice clean thing. Scale it up to fill up picture as much as possible, and we have to define our outputs. What are our outputs? Of course the basic shape, which is sweep 1, then symmetry 7, symmetry 9, this is correct, but why the symmetry 8 is not selected is quite a question. But anyway, we need that one as well, and that will be it. So now we have our template completely defined, so it's stored in knowledge templates. It needs for some reason again update. Why? It's always hard to say, even though it's not really updatable. Local update will update it, global update won't, but we have a geometry which is now complete. We will save this model and we will import it in the other model where the realistic supporting curves and surfaces are coming on which this element will be applied then. So let's save it.